there is also another way to visualize or to sketch the magnetic field lines around a bar magnet. So let's try that method too. Take a white sheet of paper and fix it on a drawing board. At the center of the paper, place a bar magnet like this. Let this be the north pole of the magnet and let this be the south pole. And place a compass needle here. And you know the compass needle will rest in north-south direction. When the compass needle is placed here, south of compass needle appears at this point because of the fact unlike poles attract and like poles repel, and north pole of the compass needle will appear here. Then mark the points like this. Remove the compass needle from here. Place the compass needle here. Again, since this is the north pole, which pole will come here? South pole, and north pole comes here. Again, mark the points here. Then again, remove the compass needle from this position and place it here. So again, the compass needle will point like this. So, and again remove this. Mark the points and remove the compass needle. Place the compass needle here. Again, the compass needle will align like this. South, north. So near the south pole, which pole of the compass needle appear? North pole. When you join all the points, you will get a pattern like this. So this is known as mapping of magnetic field, and this is also a method to sketch the magnetic lines of a bar magnet. So how will you define a magnetic field line? From this activity, we can define a magnetic field line. Magnetic field line is an imaginary line because it doesn't exist actually, we are sketching it. So it's an imaginary line along which north pole would move if it is free to do so. So here we are considering only the north pole of the compass needle. So along this magnetic field line, a north pole will move freely. So this is the definition for a magnetic field line. What is that? A magnetic field line is an imaginary line along which the north pole of a compass needle will move or would move. Okay. So this is the pattern of magnetic field lines around a bar magnet. Here you can see one thing. Near the ends of the bar magnet, the ends of the magnet is known as pole. So this is the south pole and this is the north pole. So near the poles, the magnetic field lines are very crowded. Here the magnetic field lines are far apart. Okay. So this is a peculiarity of the magnetic field lines of a bar magnet. So once again, let's go through the definition for magnetic field lines. Magnetic field lines are imaginary lines along which a north pole of a magnet would move. From the figure, we can easily list out the properties of magnetic field lines. See, this field lines emerges from the north pole and merges at the south pole. See the direction, it's from north to south. Here also direction is from north to south. Okay, but inside the magnet, the direction is from south to north. Now, near the second property is near the poles or near the magnet, the field lines are crowded. So the closeness of the field lines indicates the relative strength of magnetic field at that point. So here the field lines are closer. That means here the field is stronger. Here also field lines are closer. So that means here also the magnetic field is stronger. Okay, but in these regions, the field lines are far apart, which means magnetic field is weak here. Here also the field lines are far apart, which indicates the weakness of magnetic field in these regions. So the closeness of the magnetic field lines indicates the relative strength of magnetic field. If the field lines are closer at any point, it means the magnetic field at that point is very strong. And if the field lines are far apart at any point, it means the magnetic field is very weak at that point. Okay. And also the next property is that no two field lines cross each other. Can you see any field lines intersecting each other? No. No two field lines intersect each other. Because if any two field lines intersect each other, it means at that point magnetic field has two directions, which is impossible. At a point magnetic field has only one direction. See, just listen. If two field lines intersect like this, it means at the point of intersection, magnetic field has two direction, which is impossible. So, two field lines will never intersect each other. That's very important question. You can expect a question like this. No two field lines intersect each other. Why? What is the reason? If two field lines intersect each other, it means at that point magnetic field has two direction, which is impossible, because a magnetic field can have only one direction at a single point. Okay. So once again, let's go through the properties of magnetic field lines. It's very important, properties of magnetic field lines. Magnetic field lines emerges from north pole and merges in south pole. Inside the magnet, field lines are from south to north pole, hence we can consider it as closed curves. The relative strength of magnetic field is determined by the degree of closeness of field lines, and no two field lines intersect each other. These are the properties of magnetic field lines. Okay children, with this I am concluding this session. Notes of this topic and a YouTube video based on this topic have been uploaded. Kindly go through that. There will be a small test paper based on this topic. So go through the questions and post me the answers as soon as possible. We will meet in the next session. Till then, stay home, stay safe. Thank you.